Let's run through some examples, as we said at the end of the last podcast. This is from the Bezos Earth Report, or whatever it's called. We are looking at the landscape of AI for applications to nature and climate, and this is on current applications of AI for nature, food and agriculture, power, cities plus built environment, greenhouse gas emissions, and climate impacts. So AI capabilities seen in each global system. We are looking at data processing, monitoring, optimization, prediction, digital twins, and accelerating discovery, as we already discussed. And you are looking here at the various items on this scale. I won't go through each of them, but you can do that on your own. Nature, which includes forest and land management, ocean management, freshwater management, as we already discussed, and we'll look at a bit more. So it's being used in these all these items except for accelerating discovery, food and agriculture in all spheres, power, all spheres, industry, all spheres of data processing, monitoring, optimization, prediction, digital twins, and accelerating discovery. Cities and built environment, apparently no accelerated discovery yet. Transport, in all of them. Greenhouse gas emissions, so technological carbon removal as well. It's not optimized yet, but it's being used for everything else. And climate impacts, again, not optimized in any sense or not used for accelerating discovery yet. So the initiative highlights on conservation and biodiversity. There are several examples like Conservation X Labs, Sentinel AI, Wildlife Insights, Conservation AI, Rainforest Connections, Arbimon. This is an open source ecoacoustic analysis platform empowering scientists and conservationists with an efficient way to upload, store, and analyze mass amounts of acoustic data, enabling the ability to derive insights about the ecosystem at scale. Earth Species Project uses AI to decode and deepen the understanding of non-human communication. I mentioned this already about discovering things about birds, elephants, whales, and so on. You know, imagine chimpanzees calling each other by name and having chit-chat, so on. And you can dream that in a few years or maybe in a decade or two, we will be so good at understanding the birds and animals and fish and so on, the whales, dolphins, that we can work with them on saving them from climate impacts. Yeah, dream, right? This is Nature Serve, the map of biodiversity importance. In collaboration with Nature Conservancy, S3, and Microsoft, NatureServe uses machine learning and cloud computing to create the map of the biodiversity importance. It's called the map of biodiversity importance. Okay, so you can see here not much details given by me, but you can go to the report and look at these things. I just want to use these examples using AI to identify species, so you can see unique strip patterns are being used, unique rosette patterns, occasional torn ears, unique rosette patterns, again similar to this one, spots on body from unique. So this is basically an example of how AI models are trained on morphology to identify and differentiate species of big cats. Okay, there is a lion with some spot that is being looked at, whisker spot pattern, whatever. Okay, so this is about ocean management. Digital twin oceans are being done. High resolution multi-dimensional representation of the Earth's oceans with nearly real-time accuracy by integrating a wide array of data sources, including sensors and satellites. The goal is to provide an interactive digital twin, as usual, of the ocean to strengthen ocean governance, restore marine habitats and biodiversity, and improve disaster risk management. This is the Allen Coral Atlas, World Wildlife Fund Manglarii, whatever. Manglaria, I don't know what that is meant to be. So this is for mangroves, obviously. World Wildlife Fund's Manglaria is AI for mangroves in Spanish, so it's reversed in Spanish. Artificial intelligence, maybe intelligentsia artificiale. I don't know. You let's figure it out. Okay. The Ocean Cleanup. Ocean Cleanup, a non-profit that develops technology to extract plastic pollution from the oceans, uses Microsoft Azure machine learning to support their efforts in cleaning up plastic and debris from the oceans. Their goal is to remove 90% of the plastic from the oceans by 2040. In the meantime, the production and plastic pollution keeps going up, so we have to really stay on top of that. This is Freshwater Management, Global Wetland Watch. So that's an alliance. Hydrogen. Researchers from Princeton University and the University of Arizona were awarded $5 million by the National Science Foundation to develop hydrogen, that is hydrologic scenario generation project, which uses AI to develop simulated models of the U.S. watershed systems. So it's not hydrogen as in H2, but hydrological scenario generation. NASA's TerraHydro, Terrestrial Environmental Rapid Replication and Assimilation hydrometeorological software, aims to revolutionize the creation of composite hydrological models using AI. There are many details that I'm skipping on purpose. Mini is a Nairobi-based startup that aims to solve environmental data scarcity in Africa. So you can see that there are government agencies involved, universities involved with funders, that is government, NASA is involved, there is African startup that is getting into this. So the entire ecosystem of innovation, governance, public-private partnerships see this as an opportunity. We keep saying climate crisis, but it's also a challenge for sure, but great opportunity to save the world and make some money, right? International Rice Research Institute, IRRI, does a lot of things. So the Fit for Future Genetic Resources Unit has received a Google.org grant to integrate AI and high-throughput phenotyping methodologies into the largest rice gene bank in the world, consisting of over 132,000 varieties from 132 countries. The phenotype is basically how things respond to environment, as opposed to genotype, where a new genetic strain can evolve. So I'm just being very brief. NASA Harvest, this is something that is run out of University of Maryland as well, Chris Justice and so on. So it's a global consortium of multidisciplinary experts led by University of Maryland, aimed at broadening the use of Earth observations to deliver critical food security and agricultural assessments. You know, I used to be at Maryland. I'm an emeritus professor at Maryland. Climax Foods is a biotechnology company that utilizes machine learning to develop plant-based alternatives to animal-derived foods. So a lot of foods, especially meat, may come out of the labs, and people may start enjoying them enough to give up on the real meat. Of course, there are details, because you have to make them taste like meat, which means some chemicals have to be put in. The fatty acids that give meat that specific taste, how do we create it with plant-based meat and so on? So obviously some time to go in terms of understanding the impacts on health that may be unintended, etc. We mentioned Internet of Things before. Internet of Things in agriculture. IoT and AI can enhance the monitoring and management of soils, crops, pests, and livestock. Nokia and the Vodafone Foundation's Smart Agriculture as a Service links field sensors and Nokia's IoT network grid through a mobile network to provide valuable and timely information to farmers via mobile and web-based applications. I said mobile twice because I was going to say mobile or mobile. So there is the link to that. So weather monitoring, crop management, crop and pest monitoring with drones, smart irrigation. You basically downscale weather to farm scales and provide irrigation advisories, livestock management, soil testing and monitoring, and machinery management, precision agriculture, smart agriculture, and so on. Uplight plus AutoGrid, so applications to power. Upright uses AI models to analyze vast amounts of energy consumption data and draw actionable insights for utility companies or their customers, allowing them to reduce energy consumption and costs. Stanford University Deep Solar project. Deep Solar, led by Stanford University, uses a deep learning framework that analyzes satellite and aerial imagery to identify GPS locations and size of solar photovoltaic panels across the world. Wind farm energy optimization, that is Google DeepMind being applied machine learning algorithms to wind farms. Multi-platform inspection, maintenance and repair in extreme environments. So this is disaster management kind of thing. Funded by Innovate UK and led by ORE Catapult, the project brought together 8 cross-sector collaborations in robotics, artificial intelligence, marine and aerial engineering, nanobiotechnology, and space missions. MIMRI used AI and robotics to automate the repair of offshore wind turbines. What do you know? It's hard to maintain them, but if you automate them, fantastic. Husk Power Systems, another power application. Open Climate Fix uses AI to improve the efficiency and effectiveness of the energy sector. Nuclear fusion, a moonshot but with tremendous potential. Google DeepMind, in collaboration with the Swiss Plasma Center, created the world's first AI system to support nuclear fusion. Nuclear fission versus fusion. Nuclear fission is considered a renewable energy with no emissions of CO2. Of course, there are lots of mining of radioactive material, radioactive waste, etc. People get scared of it, but fusion is still not fully functional yet, but lots of money is going into it. Lots of players are involved in making it better. Applications to industries. Cement production accounts for roughly 8% of the world's total CO2 emissions and is a major hurdle for greener industry given its ubiquitous use. I've discussed reducing cement greenhouse gas emissions elsewhere already, but here are some examples. AI Crete's operating platform uses AI, machine learning and computer vision to generate factory insights that help producers optimize concrete mix designs and operations to lower production costs, increase profit margins, and reduce, of course, overall carbon footprints. Similarly, you have Carbon Rees, Delta Zero Cement, Cimex, which uses machine learning to advance function of ball mills, specifically the most energy-intensive part of the production process, by collecting data in real time and making adjustments automatically based on that data, resulting in lower energy consumption and a higher quality product. Concrete.ai, another application for cement. There is also steel. Ferrolab's explainable AI enabling circular manufacturing workflows to decarbonize the steel, chemicals, and cement industries. So it's attacking multiple industries. Atlas AI has developed a number of AI-driven geospatial tools that assist infrastructure actors in historically untapped, undeserved markets. So that's going into cities and built infrastructure, built environment, as we call it. The Materials Project takes an extraordinary amount of time and money to synthesize, characterize, and experimentally validate new materials in the physical world. The Materials Project makes the process virtual with AI and machine learning, training models on The Materials Project makes the process virtual with AI and machine learning, training models on vast amounts of data such as crystal structures and chemical composition of existing materials in its dataset, which then generate novel materials and predict their properties, so accelerating discovery, as we called it. Optimization and building decarbonization, which is very important because building energy demand and emissions are expected to keep going up till 2050, especially as India and China keep building more and more buildings, infrastructure, and so on. Brainbox AI, Delve, Mortar.io, Building X, Block Power, etc. are all working on reducing carbon emissions. Urban AI is a think tank focused on conducting research that can assist city leaders, urban planners, and policymakers in understanding the state of urban technologies, AI models that are currently applied to cities and the built environment, and the potential for AI to make urban life safer and more sustainable. University of Virginia Link Lab, the multidisciplinary consortium of faculty and graduate students conducting research in smart and connected health. hardware for IoT and smart cities. And this is Treefolio NYC, the result of a multi-year collaboration between Cornell University's Design Across Scales Lab and Cornell Tech's Urban Tech Hub. Treefolio NYC is a digital twin of New York City's tree canopy. Not the entire city, but just the tree canopy. And New York City is an amazingly green place, and you can see the digital twin here. Google's Environmental Insight Explorer, this is doing some related biodiversity and urban management as well. So building transportation emissions tool can monitor air quality, solar rooftop potential, and tree canopy coverage. Gray Parrot works on waste intelligence to improve recycling and help address the global waste crisis. So just look at the breadth of the applications that are focused on nature, greenhouse gases, and so on. Greenlight is a Google research initiative. Google is putting a lot of money into these. Obviously, they have a lot of disposable wealth, I suppose, plus they see a potential payoff as well. So this optimizes traffic lights to reduce vehicle emissions. What do you know? Chemix Mix platform, a California tech startup using its Mix platform to apply AI and machine learning to EV battery design. Project Contrails, obviously you know what that is. Contrails from airlines and ships can be significant contributors to global warming because they allow sunlight to come in and block outgoing thermal radiation, so they have to be dealt with as well. Parallel Systems is a startup founded by SpaceX engineers, Elon Musk there, builds modular electric freight cars which are much cleaner than traditional rail cars with fully automated systems that use machine learning to help optimize routes, energy consumption, and scheduling. Just imagine all these applications. K-Rose and Climate Trace, this is an example of global environmental intelligence company that measures the effect of human activity on the environment at global level. Uses science, AI, real-time satellite imagery. Kairos aims to reduce GHG emissions through measurement and attribution, manage energy transitions, and protect populations, ecosystems, and assets, modeling both climate risk as well as biomass and biodiversity for voluntary carbon credits. So they're covering many aspects of managing energy, emissions, and offsets, etc. Perennial is the leading measurement, reporting, and verification platform for soil-based carbon removal, soil CDR, very important. Proving that you are doing additional carbon sequestration is always tricky, so this kind of platform helps that. Heriot-Watt University Eco AI is a UKRI Foundation project to address key barriers for large-scale carbon capture and storage implementation, including high energy demands of the capture process, high costs for predicting and monitoring, and uncertainties in financing CCS projects, and lack of understanding of the impact of regulatory and or market interventions. Okay, so should I keep going? Yeah, so let's finish this and come back to the next podcast. Argonne National Laboratory is using AI to identify new materials for carbon capture through generative AI to dream up previously unknown building block candidates, machine learning, and high throughput screening of candidate materials, so accelerating discovery there. Carbon Cure Technologies develops innovative concrete solutions aimed at reducing carbon emissions. Stanford University's CCSNet creates digital twins for carbon capture and storage, and this is kind of a monitoring site here. Alert California monitoring feeds, so all the instruments are set up and you can you are looking at all the data. I think this one is particularly focused on wildfires, if I'm not mistaken, but you can look it up. You get the idea that literally all aspects of climate impacts, biodiversity, built infrastructure, food, agriculture, power, transportation, everything is already being covered by AI. So what is left? We can look at how large language models in the co-production of climate impacts can work. So we'll come back and look at this in the next podcast and look at a few more on predictions, digital twins, and then go to barriers to progress. So if everything is going so happily, then what remains? What are the barriers that we have to worry about? So let's do that in the next podcast, just to keep this reasonably short or long, depending on what your attention span is. Okay, see you in the next podcast. We should be able to wrap it up in the next podcast, I hope, I suspect. If not, we'll make 2 more. No harm, right? So see you.